Hello everyone, today let's discuss a question from Edexcel 2022 Further Maths A-Level Pure paper. So this is the last question on that paper. As you can see that we need to solve a second order differential equation. For question A, part 1, we need to prove that the particular solution is theta equals 1 over 12t sine 3t. Therefore, we can set our particular equation, let it be lambda times t sine 3t. So we only need to determine that lambda is 1 over 12. Therefore, we need to find the d theta star dt. That gives us lambda sine 3t plus 3 lambda t cosine 3t using the chain rule and the product rule. And then the second derivative will be 3 lambda cosine 3t, then plus 3 lambda cosine 3t, then minus 3 lambda t, 9 lambda t sine 3t, using again product rule and the chain rule. So to summarize this, collect terms, we have 6 lambda cosine 3t minus 9 lambda t sine 3t. Then we need to plug in, substitute back into the original differential equation, that is 6 lambda cosine 3t minus 9 lambda t sine 3t. Then plus 9 theta, which is 9 lambda t sine 3t, that equals 1/2 cosine 3t. Okay, so 9 lambda t sine 3t will be cancelled, and then we have 6 lambda cosine 3t equals 1/2 cosine 3t. So that means 6 lambda equals 1/2, that gives us lambda equals 1 over 12, so which proves theta star equals 1 over 12 t sine 3t. So that is part 1. So part 2, we need to solve for the general solution of the differential equation. Since we already have the particular solution, we just need to find the general solution for the homogeneous differential equation, namely d squared theta dt squared plus 9 theta equals 0. So we know the characteristic polynomial will be m squared plus 9 equals 0. That follows with these roots of m equals plus minus 3i. Since they are pure imaginary part, so the e function part in the general solution will be disappeared. That means our general solution for the homogeneous equation will be a cosine 3t, from the 3 is from here, from the roots imaginary part, plus b sine 3t. Then plus the particular solution, which is 1 over 12t sine 3t, we have our general solution. So for part B, for part 2. So now for question B, we are given an initial condition. Initially, the pendulum makes an angle of pi-3 radians with the downward vertical, and also is at rest. Those are two very important information that give us an initial value of theta at t equals 0, also give us a initial value of d theta dt at t equals 0. So given that 10 seconds after it begins to move, the pendulum makes an angle of alpha radians with the downward vertical, you need to determine that according to the model, the value of alpha to 3 significant figures. So we need to find out what alpha is. So alpha actually is theta evaluated at t equals 10. So what can we do? We need to first determine those two constants in theta. So using the two initial conditions, when 10 equals 0, theta equals pi third, that follows with with pi third equals a times cosine 0, which is just a, and sine 0 is 0, so we just plus 0 plus 0. That follows a is just pi third. Now for the second condition is when t equals 0, d theta dt equals 0 because it's at the rest. So we have 0 equals, we need to differentiate the theta, which give us minus 3a sine 3t. And in the second part, we have plus 3b cosine 3t. And last, we have a product rule that is 1 over 12 sine 3t. Then we have to plus 1 over 12t and 3 over 12t cosine 3t. So we know when t equals 0, sine will be cancelled. So only 2 cosine left. But since t equals 0, the last part also is 0. Therefore, we're left with 3b. 3b equals 0 implies b equals 0. Therefore, our theta actually is, for this particular initial condition, is pi third cosine 3t. And since b is 0, we have to plus the rest, which is 1/2 1 over 12t sine 3t. Okay, now we need to evaluate when t equals 10. Put it into the function. We have cosine 30 radians plus 10 over 12 sine 30. Then put it into your calculator. The answer will be plus minus 0.662. So that is answer for part B. For part C, you can see that the true value is 0.62. How about this model? But since 0.62 is very close to 0.662, so that means it's a good model. So the last part, part D, we need to refine the differential equation so that the motion of the pendulum is a simple harmonic motion. So there will be no function of f of x on the right-hand side, f of t, sorry. So that means the model, the differential equation, should be refined as theta dash dash plus 9 theta equals 0. So that is all the solution. As you can see, it just follow the standard and the basic definition and properties of second order differential equations. No complicated logic, no difficult calculation. You just need to follow the rules and you will eventually have the correct answer. I hope you understand the solution, enjoy the video, and see you in the next. Bye.